Hello, how are you doing? So we are going to continue with the second part of just reviewing that practice test number 3 for you, especially talking with the application of the AutoStats in order to check our solutions. Okay, so we did all the problems regarding to the confidence interval for the mean, two cases. The case that the population standard deviation is given to us. Okay. And the second case that the population standard deviation is not going to be given, but the sample size is small. So in the first case, we use the z-test and the z-values, okay, and the other case, we use the t-test and the t-distribution, okay, and I'll show you how you do it using the application or the table, or you can use TI 8384. So we go to the next topic. The next topic that we have is the proportion, population proportion. Talk about the confidence interval. You can have confidence interval and the test hypothesis. The test hypothesis of the mean and the population proportion are very similar. So we usually go with the mean. But expect at least one problem regarding the population proportion, confidence interval for the proportion on the test, okay? So let me just bring the practice test again. We continue. Okay. Share it to see what problem we are going to do. Okay, there you are. We are going to go to the problem number 7. This is about the proportion. So read it carefully because the other one were about the mean. This is about the proportion. Just make sure you know what we are doing. In number 7, that's it, a survey of 300. We did this one before, but I just put it over here. Just make sure you read it. Survey of 300 union members in New York State reveals that 112 favor a Republican candidates. So the sample size is 300. The number in favor or in your interest, we call it R, is 112. So it's a proportion of the 300. Construct a 98% confidence interval for population proportion, okay, of those members who favor a Republican candidates. So in the case of the proportion problem is easy because you would just be given 3 numbers. These 2 numbers, the bigger one is the sample size, which is going to be n. Okay, the smaller one is going to be the one in interest, your interest, we call it R. Okay, and only the confidence level would be given C. So only 3 numbers. Okay, you know that you are going to find the sample proportion, you're dividing 100 over 300, and we have the z-test for this one and a formula and do it right away, and we can do it with the application. So let me just go back to my notebook and explain the solution that we have. You did all right, most of you, on the quiz, because we give you one of these questions, and you should be fine doing it again on the test and on the final, of course. So we get one problem regarding the confidence interval proportion on the final. Okay, I'm waiting to get to my notebook. This is it. So this is a situation that we're going to have for the confidence interval for the population. This is the formula. Remember, we need to find the E. E is ZC, square root of P hat Q hat over N. It's like a binomial distribution. P probability of success, Q probability of failure. In your book, they call it P times 1 minus P. But we call it PQ, which is the same thing. Okay, so it's going to be probability of success. So that's our formula. It's always z-test. So the p hat is going to be r over n, and the q hat is 1 minus p. So the sample information, as we talk about it, n is 300, r is 112, c of 98%. We find the p hat, which is r over n, that give you the p hat. Then the complement give you the q hat. Okay, so 98%, then you go to your table, you find the critical value, which is 2.83, you substitute, simplify, that give you your E, which is 0.065. Okay, and the formula this time is going to be P between P hat minus E and the P hat plus E. You substitute, simplify, the final answer must be given in percent because this is just a proportion. So make a comment. Remember that was about the proportion of the people who were in favor of a Republican candidate. So the confidence level of 98%, so there is a 98% chance that the population proportion is going to be between 30% and the 43.5%. Okay, so a straightforward problem, and it can be done manually if you like, but I just show you how you are going to find it on the ArtStat application. Okay, so it's very easy to do it with that application too. But again, you identify the information about the sample forest, okay? And then you go to your ArtStat and you make an interval, and then you are going to make a comment at the end. Okay, there you are. You have to go to the web, and you need to go to the proportion this time. Okay, the same thing that we did for the confidence interval for the mean. So that's going to be the case. You see, the one that we did, the inference for the mean. So this is going to be inference for the proportion. So we get this one. Then you have to put the information, okay, that we need to talk about it. So this is it, confidence interval. So the number that we're going to put, you go with the number of successes in this case, okay? Number of successes means P. No, R. R is samples, okay? We go with the sample size of the 300. The one in favor, this is the interest variable, is 112. Remember, a portion of 300 were the people who were in favor of the Republican candidate. Okay, so we are not going to, we have the confidence interval. The only thing that you have to put is our confidence level of the 98%. That's a 98%. There you are. Again, you identify the marginal error for us. The marginal error is 0.065, exactly the one that we find. Okay, so if you want to use this system, a screenshot or just identify the marginal error, you have to identify the sample information that you're using, then the marginal error, which is E, and the interval. The interval is almost like the one that we did. This is a 31%, and this is going to be, you see, 43 or 44%. So almost like the one that we did, okay? You make a comment, there is a 98% chance, 98% chance that the population between 31% and 44% of those population are in favor of a Republican candidate. Okay, so it's very straightforward as we did it before. Okay, so identify the marginal error that you got over here and the information about your sample, interval, and make a comment and be accepted right away. Okay, so that's a population confidence interval for the population proportion. So this is it. We have another one, which is very similar. Again, this is the one that we gave you on your previous practice. Okay, previous practice that was quiz. So I just check it again. So that's number 7. Okay, so we have the, just share it again. So that was number 7. We have number 8. Very similar. We talk about the student in the college that own their own car. We pick sample of 343. Okay, and we find out that 110 owns car. So 343 would be the sample size, or number of successes would be 110. We want to find the confidence interval with the level of the 99% for everybody. Okay, sorry, for everybody that you got a car. Okay, so the solution is this one, very similar. So the sample information is this. We survey 343 people, 110 owns the car, confidence level 99%. So it's a proportion marginal error. You have to find the p-hat, the portion who owns the car. 0.32, you have the q-hat, C of 99%. You got it from the ZC table, 2.58, and you simplified. Your E is going to be similar, 0.065. And you substitute P between P hat and E, P hat minus E, and you get the percentage of the people that would have a car in the college in general. So there is a 99% chance that, okay, that the population proportion is between 25% to 25.5 and 38.5, okay? So this means in general, between 25.5% and 38.5% of the population would own the car. Okay, so it's straightforward, and same thing with the table. Again, I can show you so that make sure you know where to find it. So if you go to the, again, art of stat, that is going to be the case. Let me share this one. We are in inference of the proportion. Again, for this one, you go with the number of successes. Number of successes, okay, the sample size. The sample size here is 343. Okay, 343, the sample size. Number of successes, the one we are interested in is going to be 110. That's a 110. Then only confidence level. Confidence level of 99. 99. There you are. So marginal error of 0.6, again, like the one that we have, 0.065. Interval of 25.5% and 38.5%. Okay, exactly the one that we got it. Again, make a comment. There is a 99%. There is a 99% chance that the population proportion are going to be between 25.5% and 38.5%. Okay, so the proportion case is always easy problem, straightforward. There is only one case, and there is no t-test for this because it's coming from the binomial distribution, and there is always one more condition that we don't check, n times p, remember, is greater than 5, n times q is greater than 5. So that was the condition that we can approximate a binomial distribution by the normal. So it's always normal. That's why you don't have any t-test for this, for the proportion. Okay, so that is going to be proportion problem. Again, I repeat it, we are not going to give you confidence interval. Test hypothesis for proportion, we are not going to give you that. Just give you one question on the confidence interval. Okay, that would take us to the second topics that we have, test hypothesis. Quite interesting and easy one. So let me just go to that test. and show you what we are going to do with this. There are 3 cases. In this case, we give you 1 from each for the test hypothesis. Now, what we're going to do, there is going to be a claim. Okay, there is going to be a claim that we're going to test it. You see somebody say something, then you have to check to see. You carry out an info. You're going to carry on a case. Okay, you're looking for some characteristic of a sample. That characteristic can be mean, can be proportion, can be a standard deviation. Okay, when we get to the final, we have all of them. But for the time being, we are going to get only the mean. So you get the information from the sample and we claim that the mean is just a specific number. But somebody will challenge you, say, oh no, I don't agree. If you see somebody challenge you, so you have to check the possible alternatives. You have to check the alternatives. At the end of the day, you may accept that is a new claim or you may reject it. So for this type of problems, you have to set up the problem carefully and then just do it. There are 4 steps. I'm going to explain it with one of these, okay? And then you can use the application, but you have to write the details of this test for us, okay? You set up the test first. So let's go to the first part and check to see how we're going to set up this test. Okay, so the situation is some information about the sample would be given. Look at this one. In this part, number 9, we have a sample of 18 people. This is the sample size. And their income are going to be below poverty level. Okay, and the daily calcium intakes is this one, on average. So basically, the sample size is equal to 18. And the sample mean is 747.6 milligrams. At 5% significant level. You see, if they say confidence level, that would be confidence interval. If they ask about significant level, this means this is test hypothesis. Significant level is your tolerance. You see the cut point, the cut level that you have. So at 5%, this is denoted by alpha. Or the confidence interval, we go with a C, but this is alpha. At alpha 5%, we want to check this claim. Do the data provide sufficient evidence to conclude that, you see, they conclude that the intake calcium for those people with a low income is less than the national level, which is 800. And the sigma is given to you. Okay, so the national average is 800 milligrams. You pick the 18 people, and you find out this number is less than. So can you, based on this information, conclude that yes, the people whose income are going to be under, okay, are going to be low income, the calcium intake is less than 800. So that's a claim that you have to test, okay? Now, just go back to my notebook and explain it. How we're going to set up the test, okay? Now, to set up the test, the way we are going to do it, we just check to see what the claim is. Okay, then we are going to test the claim. So you have to set up this test for us, okay? We don't accept that if you just give us some numbers and the conclusion, we're going to question you right away. Because it's important to see how you set up this test, okay? So you identify what is the claim is. The claim is that the average intake of the calcium is less than 800. Then you have a sample. You have to give a sample information. The sample information is we pick 18 people. We find their average intake, 747. Then we want to check it against the alpha. Alpha is going to be that probability or the significant level, 5%. Sigma is given to you. It's the same thing like you did before. If the sigma is given to you, this would end up with a z-test. If the sigma is not given to you, and the sample size is less than 30, you have to use the t-test. So there are two different tests. So you have to identify which tests are going to use, okay? That's very important to identify the test for us. So how are we going to set up the claim? You see there is going to be something, we call it null hypothesis, null, zero. We call it H0. We identify H0 as equality sign all the time. There are different options, but if you call this one equality, it's the easiest case. So whatever number is you want to claim, you're going to put it here. Say H0 is that the mu is equal to the 800. Then H1 would be the one that you want to check, alternative. Okay, write the first one always a specific number equal to, we call it mu naught. And your alternative mu less than 800. Now, eventually we are going to find the probability that the mu is less than 800. So when it's a probability, it's going to be z score, okay, and it's going to be something like, or that z is going to be less than some z naught. That's why we refer to this as a left tail test. If it's going to be less, left tail test. If it's going to be greater than, we say right tail test. If it's going to be not equal to, we say two tail test. Okay, it's important because when you want to use the application, the numbers and the solutions would be different. Okay, less, greater than, not equal to. Less, left tail, or just one tail. Greater than, right. Not equal to, we say two tail. So that's first step that you have to identify. Second machine, the test. The test, we have two tests, Z or T. You have to tell us which one are going to use. You check to see if the population is standard, like the confidence interval. If the population standard deviation is given to you, use the z-test. If this is missing and the sample size is small, use the t-test. If you use the z-test, the formula is x bar minus mu naught. This is mu naught, 800. And we call this one z naught because it's going to be just number, one number. Okay, it's going to be x bar minus mu naught over sigma over radical n. This is z. If this sigma is not given to you, you have to use S here. Sample standard deviation. So that would be T. So T naught, Z naught. Okay? You substitute the X bar and the mu naught. Mu naught, this is 800. You find it, it's going to be negative 1.19. So that's a Z number. Okay? That's the second step. The next step, probability. What's the chance that this would happen? We call it p-value. There are different methods to find this. The p-value method, P stands for probability. It's very easy, easier than any other methods. If you read your book, they give you two different sections on this one. P-value and the critical values, but the p-value is easier. Even all, but we don't mind whichever you want to use. I use the p-value because it's easy. Now the p-value is just a probability. You see probability that the z is less than, less than, greater than, not equal to, not equal to. Three cases. So as soon as you write it down, this would be just area to the left of the z. You can use the application or you can use the z table. Okay, whichever you feel more comfortable. You see the z table? Remember, you want it's negative 1.19. Just exactly area to the left. You see that's a negative 1.19. Okay, point 0.1. We go with the 0.1, then the 9. You see the 9 would be this last one. So that gives you 0.1170. And again, the applications calculator give you the number here. So this would be something like 11.7%. So this is the probability, 11.7%. Okay, so that's a step 3. A step 4, conclusion. What's going to be the conclusion? You see, the conclusion is, remember at the beginning of the course, we set up 5%. We say anything less than 5% is not going to happen if you like. But it's something similar, but this alpha would be given to you. So you're not going to use, it may be 5%, maybe 1%, okay, 2%, etc. So you compare your P number with the alpha. If P is less than alpha, you reject the H naught. That is statement that you have. If P is greater than alpha, you do not reject the H naught. Okay, so P less than alpha, reject the H naught. P greater than alpha, do not reject the H naught. Now then you have to make a comment and tell us whether you are going to, what are you going to do about the claim? Okay, this doesn't mean anything if you write it down as is. You have to explain it. Now what's going to be the explanation? You see, when we say do not reject the H naught, means you are in favor of H naught. But remember, we did have an alternative. So it's either this or this. So if you do not reject the H naught, means you are in favor of the H naught. So this means you are going to reject this one, or you are not going to support this one. So you have to make a comment for us. Comment for us, okay? So the comment is going to be, since you want to reject it, you write something negative for it. Say, oh, there is not sufficient evidence to conclude that mu is less than 800. You see this one? If you accept it, you say there is. But again, I repeat it. Do not reject the H naught, means you are favoring H naught. If you believe in H naught, so you don't believe in H1. So something negative. There is not sufficient evidence to conclude that mu is less than 800. But that was your claim. So we say do not support the claim. Okay, they say do not support the claim, or sometimes they say refute. Okay, refute the claim. Okay, so we don't, the word reject is very, very strong for this one, because it's just based on this information that you have. Usually say do not support the claim. Okay, so that's how you set up this problem to be able to do it. Now, what you can do is you can set up the problem for us. Okay, you set up your problem, you tell us which tests are going to use, then you can get these, okay, the bottom one from the application. But remember, if you just give us set up numbers, I just put a question mark for you, because it's very important to set up the test. Okay, what are you talking about? We need the H naught, we need the H1, we need to find out which tests are going to use for this evaluation over here. Okay, you can do it quickly with the application problem, or you can use it calculator or any of those applications that we talk about. Okay, so be careful. Let me show you how you can, it can be done easily for this, but let me show you how are going to, or where are going to find it. If you want to use the application problem, okay, so there you are. Now, you go to the ArtStat, okay, again, you go to the same place that we did have, confidence interval. Okay, confidence interval, that was the, okay, we're focusing on the mean. So this is going to be the mean. That's it. We do the same thing. There are two cases. If the numbers are given to you, you are going to say this, but since we have the short information, summary of result, like the one that you did before. But look at this. When we did it before, we were looking for the confidence interval. Confidence interval. But now you are going to do a test hypothesis called significant test. Make sure change it. Okay? Significant test. Now put the information that you have. Information that we need is sample mean, Sample mean is given to you. It's a 747.4. That is the sample mean. Sample standard deviation, okay? You know, it's again, if you want to put the population, you have to use your cell phone, but it's all right. You can use this one too, that give you the same answer. Okay, you put the sigma, which is 188. Okay, that's going to be 188. So we need a sample size of 18. Sample size of 18. Okay, so these are going to be the case, but you have something else to take care of. This is the value for the null value, mu0. Mu0 was 800. 800. Okay, the type of the test that we're going to use, you see this one? Is it two-sided, less, greater? This is where you put your claims, okay? Less, greater than, and this is not equal to. In this case, remember the mu was less than 80. Less than. You see, if you put this one, now you have all the information that you need. Look at this. This is what you set up. Mu equal to the 800. Mu0 is mu less than 800. Test statistics, you know, since we don't have the cell phone version, this is used T all the time, right? It doesn't matter. We get the same value that we did. Okay, so you have to get the conclusion that you need. What's the conclusion? In order to get the conclusion, you click here, test decision. This is going to be your test decision. You see the p-value that you have? The p-value is 12.58, which is almost 13%. The one that I have is 12%. So you get this one and you explain it. The explanation is going to be that this is p. Your alpha is 5%. So look at this one. So the p-value is 12% or 0.12. But the alpha is 0.05. So p is greater than alpha. When p is greater than, you have to explain this to yourself. You have to add something extra for us. P greater than alpha, you write P greater over here. You bring this information down. P greater than alpha. So in that case, do not reject the H0. If you do not reject the H0, then you can write this. You see, like the one I did. There is sufficient evidence that the population mean is significantly less than 800. Okay? So then you say that I do not support the claim. Okay, so this format that you got over here, they give you the p-value, but you have to make a conclusion yourself. So the p-value is almost 12%. Your alpha is only 5%. So p is greater than alpha. If p is greater than alpha, do not reject the H0. When you do not reject the H0, you are going to accept the H1. Sorry, this means you are going to keep the H1. You have to reject the H1. So that's why we say there is insufficient evidence to conclude that the mu is less than 800, so do not support the claim. Okay, so that conclusion is very important for us. Okay, and remember this is a significant level. That's good. So be careful when you write it down. You have to explain it because this is kind of conclusion and your understanding of the result. How we're going to write it down. And so again, set up the test. You can get a screenshot of this one to provide it, but you have to compare the p-value with the alpha and make a conclusion and tell us what are we going to do. Are we going to accept the claim, or are we going to support the claim, or you are not going to support the claim? Okay, so be careful and be nice to write it down to explain it for us. Very nice test. Okay, it's very easy. You don't have to do much really to get it through. So that's a case one. So let's go back. So it's exactly the way you see the p-value is, in this case, they got 12%. We got something similar. We got 11.7, which is almost like the 12%, okay? So this is it, you see. And the reason is that in that version on the web, the web used the z-test, which is very, use the t-test, don't have the exact numbers. But the conclusion would be the same, and we accept that if you do it. Okay, but make sure that you set up this test. Okay, you have to tell us what you mean. Okay, these information must be provided. Otherwise, you won't get any point for it if you just give us the numbers. Because it doesn't make sense. You have to connect something you propose, okay, and at the end, you are going to reject or you are going to accept. So that's a big deal to write it down correctly. Okay, there are three cases: less than, greater than, not equal to. We give you a couple of them, okay, and we repeat it. There are 6 possibilities of these problems for this test and the final. So uh, let's go back and get back to the test. Okay, so that was the problem. So going back and going back to the test, I explain the next problem for you. So that was number 9. So in the case of the number 9, everything was nicely given. We didn't have to do anything extra. Sigma was given to you. So we go to the next one. The next one, number 10, read it again carefully. You want to check how tall are college hockey players. So we pick a number of them. The average height has been 68.3 inches. Okay, so that's the thing that we know it. That's a kind of claim. So we pick a group of people, okay, hockey players. We pick 14. Okay, 14, and we find out that height is higher or larger. Okay, that's 169.1. So we have a normal distribution. Sigma is given to you. Okay, so we want to check, does this indicate that the population mean height is different? Okay, that's one, different. So you focus on this. You say the other one was less than, less than. This is how you set up your, okay, your test. So the H note is going to be the claim that we're going to change, the claim about the mean. So we want to check to see if the mu is not equal to the 68.3. So we set it up and against the 5%, okay? So that's it, sample size 14, sample size 14, sample mean 69.1, population standard deviation is given to 6.9, okay? And you want to check it against the level of significance of the 5% to find out that if the population, if the height of the population of all hockey players is going to be bigger than, different from 68.3, okay? So let's go back to my notebook and set it up. So setting up is going to be, there is a claim that we want to check. So the claim that we check is, they say, is there any evidence to believe that it's not equal to 68.3? So we need sample information. Sample data is sample size, 14. Sample mean, 69.1. We have the sample standard deviation, 0.9, and the alpha equal to the 5%. So you set up H naught. As we talk about it, H naught is always mu equal to this number that given to you. So alternative that you want to check is not equal to. Since it's not equal to, it's called true tail test. Okay, less than, greater than, or different. For the different, we can call it two-sided when you use the application, or two-tail. Test a statistic, again, sigma is given to you, so we have to use the z-test. Your Z naught would be X bar minus mu naught. Mu naught is 68.3. Okay, sigma over radical n, that give you 3.33. So that's a Z naught. Now the p-value, probability. You want to find the probability that Z is not equal to the Z naught. You see, for this one, if you want to do it manually, you got to be careful. For the not, we are going to put this 3.33 and its symmetric part, negative 3.33. So your mean value is going to be, because your number is going to be not equal to these two, for example. So the p-value would be this part and this part. They are symmetric. So this is going to be half of the p-value, and this is going to be the half of the p-value. So you have to find them and add them together. Now, we have two choices. We can find one of these, multiply by 2. So find the area to the right or area to the left, multiply by 2. Area to the left is easier because we can easily read it from the table. So you are going to find twice of the probability that Z is less than negative 0.33. So you go to the table and you find the area corresponds to the negative 3.3. You see? That is going to be negative 3.3. Okay, negative 3.3, 1, 2, 3. This is it. So in the case of negative 0.33, you get 0, 0, 0, 4. So one area would be 0, 0, 4. You multiply by 2, that gives a very small number, 0, 0, 0, 0, 8. Okay, so that's going to be your probability, which is almost 0. Now you compare it with the alpha. Alpha is 5%, which is 0.05, and the p is very small number. So p is less than alpha. When it's less than alpha, you reject H naught. If it's going to be greater than or equal to the alpha, do not reject. Now, if you reject H naught, this means you believe in H1. So you have to write something nice about the H1. So there is sufficient evidence. Okay, because you are going to support the H1. There is sufficient evidence to conclude that the mu is not equal to the 68.3. So this time you're going to support the claim. Okay, so based on this information, you are going to arrive at this conclusion. Okay, so you got to be careful when it's a two-sided. You find one of this area and then you multiply by 2. The left is easier because that gives you the direct numbers. Because the right, you know that you have to find the complement. So you better find the left. Both of them are the same. So multiply by 2, that gives you probability, which is very small. You compare it with alpha, p is less than alpha. When it's less than alpha, you reject H naught. It's greater than, you do not. When you reject the H naught, so you have to support the H1. Something positive about the H1. There is sufficient evidence to conclude that H1 is true. H1 is mu not equal to 68.3, and you support the claim. Okay? So let's go to the application, especially to see how we're going to do it when it's a two-sided. So going back to the application and give you this information. Okay, there you are. This is inference for the mean. Again, go for the brief case. We go with the number of successes here. Summary statistics. Summary statistic. So the summary statistics, they ask for the sample size. The sample size is 14. So we give a sample size which is 14. Then we need a sample mean. Sample mean 69.1. 69.1. That's a sample mean. Okay, then we need the sample standard deviation. It's a point. Okay, that's it. It's 0.9. That give you the 0.9. Then the type of test you are going to have the significant test. What type do you have? You see, look at this, it's not less than, greater than, it's a two-sided. It's a two-sided value for the null hypothesis. The value was 68, okay, 68.3, 68.3. 68.3, and the value for the alpha, okay, we need the test decision. You put the alpha here, alpha is 5%. It's not the case that always would be 5%, but it's 5%. There you are. We get the conclusion. You see nicely the tests that confirm your writing. You see H naught mu 68.3, H naught, that's a H1, which is not equal to, you see the p-value, get this one, 0.000555. So you bring this p-value, you identify, you compare it with the alpha of 5%. So p is less than, look at this. We reject, this is it, p-value is less. So that conclude that, that's it, we reject the H naught. We reject the H naught, so something positive about H1, conclude that population mean is significantly different from 68.3. So we support the claim. Okay? So it's nicely done. So a screenshot of your information here, because there are quite a lot. Okay? Or otherwise, make sure that you write it down as I put it over here, that conclusion, the last part. Comparison, see, you have to compare them together. You have to compare them together and make a comment. See what are going to do about it. Okay? Nice, very nice application over here. So make sure where you are and just put them together. Okay, so that is something we call it case one. So look at this. So what we did is like the confidence interval. In these two problems, briefly the information was given to you. And what's going to be the other case? The other case is everyday life. The other case is the actual numbers would be given to you. Look at this. So let me just make sure you have it. You see, this is the one we did so far. In the 9 and the 10. You see the summary of information was given to you, then you test it. It's like the confidence interval. Look at this, everyday life problem. In this format, the values, the data values are given. So again, you have extra job. The extra job is you have to find the X bar and the S yourself. But you can use application for this one. Okay, if you drop it into the application, automatically you will get the X bar and the S and do the job. Okay, so what's the situation? How long does it take to have food delivered? Okay, it's about delivery of the Chinese restaurant. So we have a Chinese restaurant advertises that delivery will be no more than 30 minutes. Okay, so they claim that they are going to deliver your food, okay, less than 30 minutes. So we want to check it. A random sample of delivery times in minutes are given. These are in minutes. So 32 minutes, 28. So this is a random sample of these. So what we would like to do is we want to know what is this based on this sample. Is it delivery time greater than 30? See, greater than. So this is the claim that you have to investigate. So the claim is that the mu is greater than 30. So you have to check it with the sample. So we need a sample size. We have it. Okay, this is it. The sample size, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 restaurants n equal to 14, but we have to find the X bar and the S. And then we set up the test. Okay, but the test is going to be greater than. So let's go back to my notebook, explain it, and then we come back and we do the Okay, we do the application. The application is going to be quick for this, but it can be done manually, but you have to find that sample mean and so. Okay, so the claim was this. Delivery time is going to be greater than 30 minutes. That's a claim. Sample data n is 14. So we have to use the application to find the mean, X bar, 30.57, and the standard deviation of 5 point. Okay, this is 5.67. And we're going to check it in a minute. Okay, 67. And you have to check it with the, okay, significant level up to 5%. So we set up the H0. H0 is always equal to H1 is the alternative, the claim. So since it's greater than, it's a right tail test. Test stat, no, you got to be careful. You see sigma is unknown and the sample size is small. You have to use the S. So you have to use the t-test. Okay, so you have to explain it, which tests are going to use for this. Okay, use the t-test. For the t-test, this is only S over radical. Previously was sigma over radical. Okay, we substitute, simplify. So that give you 0.363. So it's going to be the t-naught, which is going to be 0.363. So we have to find the p-value. You better find it with this application. I'll show you if you want to do it without applications. So you have to find the probability that t is greater than t-naught. This is going to be the number. You see, the application, of course, give you the one, but if you want to use calculator or this one, it would be fun to know it. You see, when you do it with the application, that give you the actual value for the p. But since you want to compare it, you don't need it. You see, look at this one if you want to do it manually. That's a t-table. There was a two row on the top that we didn't use it. This is one tail area. This is two tail area. And these are alpha percentage. I've already posted this one for you. So it's 25%. Okay, that is going to be 10%. Okay, this is 5%, 2%, etc. But for the one tail area and two tail area would be different. Now, in this case that we did have, we have the sample size of 14. See, this is a sample size of 14. You have to find the degree of freedom. The degree of freedom is 13. So what you do is you go to the 13. You see that's a 13. And you match this one with the C number in the one tail area. You see that's a one tail area. And C of the 5% is here. So look at this. So that's a 13, 5%. You see, that's a 5%. You look at this number. Look at this number. Is 1.771. 1.771. Look at this. So it's a 1.771. But what is your number? Your T0 is 0.363. You see, if we go to the right, this number is getting bigger and bigger. If you go to the left, this number is going to be smaller and smaller. So your value is here. Okay, because it's less. So what you have to do is for your p-value is you just pick one of these p-values to the left of this number. You see, that's 5%. If you look at the number to this left, this is going to be 0.05. This is 0.07. That's 7.5%. So this means your p-value is bigger than this. Okay, so I explain it here again. You go to the D of the 13, you find the 177. You compare your number. Your number is less, you go to this side. So your p-value is here. Any number to the left of the alpha, all of them are bigger than. You just pick the first one. So P is greater than alpha. You know that when P is greater than alpha, do not reject the H naught. You see, because we don't need the value of the P. So this is if you want to do it manually. Again, do not reject the H naught means you want to keep the H naught. So you have to, okay, you have to get rid of H1. So you write something negative about H1. There is not sufficient evidence to conclude that the mu is greater than 30 minutes. Okay? And this means we do not support the claim. Okay, because the claim was the delivery time is going to be less than, okay, it's going to be less than 30 minutes. Okay, so this is going to be the case. Okay, but you can do this one with the application, which is much, much easier because it takes time because all those numbers. Okay, so let's go back. Do the application, but you need to put this number into the application. Okay, so let's go back. So this is the one that we have. So I need to get this number and let's go back. Let me just, because the values are given. Okay, I'm going to paste these values into the application. Copy this. Then we go to the art of stat. Okay, going back to the art of stat. This is it. See, now you have to change this one and using your own. So bring those numbers here. There you are. You see the sample mean 30.57 that I gave you, and the standard deviation of 5.28. Okay, so bring the other information. So what we need, our test is test of significant test. So for the significant test, we have to give the value for the, okay, the null hypothesis. The value is 30 minutes, so that would be 30. Then the test was greater than, okay, what else? And that's it. We have the information here. Look at this one. B equal to the 30, bigger than 30. You see the p-value is 0.36, 36%. Very, very large. And you know that this is going to be bigger than alpha, as we proved it. But get the test decision, alpha of the 5%, there you are. This is exactly what we conclude. So the conclusion is that the p-value is 36%, so the p is greater than alpha. When p is greater than alpha, we fail to reject the H naught, okay? Do not reject the H naught or fail to reject the H naught. So we have to write something negative about the claim. There is insufficient evidence that the population mean is going to be greater than 30. So this means we do not support the claim. Okay, very nice application over here. Especially for this, an everyday life problem is going to be of this type, because you are going to be given these values, individual values would be given to you. So that would be the best way to do it. Okay. Again, make sure that when you do it, you have to give us what you mean by the H naught. What is going to be your H1, H2? What type of test did you use? Did you use the t-test or the z-test? Okay. And then the conclusion. You get the p-value, 36%, as you did it over here. You compare it. Okay, a screenshot of this would be the best way to do it. Otherwise, you write the conclusion as it's here, and in order to get it, make sure to click here. Click, you get the test decision. Test decision, the important part is here, is greater than, you have to identify it, greater than, and you have to put the null value here to be able to get it. Okay. So we give you one of them. Make sure you practice to be able to do it because it takes, okay, it takes time to be able to do it. Okay. I don't know whether you get it now. I just repeat it again because I think I didn't share it. I'm not sure. So what I did is I just repeat it again. Okay, in case you didn't get that. So what I did, I just put the numbers here. So for this case, we have to use our own. So that was the number. Then the test is significant test. The null hypothesis is 30. You have to use greater than, okay, and the null value is 30. Put the test decision. So as you can see, the p-value is going to be 36%. Your alpha is only 5%. So p is greater than alpha. So we do not reject the H naught. They use this expression, we fail to reject, which is the same thing. And then you write something negative about the claim. There is insufficient evidence that the mu is greater than 30 minutes. So we do not support the claim. Okay, so get this one done. It's very easy application. Okay, so we have, I think, one more to practice on this one. I'm going to explain that one too. So getting back to again, practice. Make sure that you are identify the information and you know where to look for. Okay, it's again the similar one. Everyday life problem, information is given. So we're looking for the retail price for bananas. In 1998, it was 51 cents per pound. Recently, maybe not now, of course. A random sample of 15 markets gave the following prices for the bananas per pound. Okay, so 15. Again, the numbers are given to you. So you have to find the standard deviation and the mean. So what do you want? Can you conclude that the current mean retail price for bananas is different from, okay? So the case is a different case. So this is how we are going to set it up. Okay. So the claim was the price of the banana per pound is 51 cents. So we want to check if it's going to be different. So that's going to be the claim. Sample information, n is 15. You find the mean of those numbers, 53.4. A standard deviation of 3.4, alpha of 5%. You set up the test. H naught is the mu is equal to the 51. H1 is not equal to 51. So it's a two-tail test. Okay, two-tail test. Again, test stats. Sigma is not given to you. You have just brief numbers. Okay, S is going to be 3.5 is given. So we have to use the T information. Okay, T test. The difference is we get the S over radical N. You substitute, the number is going to be 2.655. T naught of 2.665. Okay. Now, if you want to find the p-value from the table that we talk about it, n equal to the 15, degree of freedom, 15 minus 1, it's going to be 14. You go to that T table, 14. You say that's a 14. So what you have to do is the 5%, but this time in the two-tail area. See, it's different. In the two-tail area, this is going to be your 5%. So 14. You see that give you 14 and the 5% and the 5% into the two-tail area. The number is going to be 2.145. Okay, 2.45, but your number is 2.6. Your number is greater than. You go to the right, Your p-value is any number to the right of the 5%. Any number. Look at this. In the true trade area, this is a 5%. Any number to the right. If you pick any number to the right, they are less. This is 0.02, 0.1. So in this case, you realize that the P is less than alpha. When P is less than alpha, you reject the H naught. If you reject the H naught, you are going to be in favor of the H1. So we say there is sufficient evidence to conclude that the H1 mu is not equal to the 51. And then you support the claim. Okay? So when you reject the H naught, means you are in favor of the H1. What is the H1? H1 is the claim. So there is sufficient evidence to conclude that mu is not equal to 51 cents. Then we support the claim. Okay, so the application again. So I have to copy those numbers and take them into the ArtStat. Okay, so that is going to be the one that we have. Okay, I take these numbers, the values, copy this. Then I go to the ArtStat. Okay, going to the I have to go back. This is it. So then we are going to paste those numbers. That's it. So what else? We are going to find a significant test. It's not equal to, but so it's a two-sided. The value for the null hypothesis is 51 cents. Okay, so that gave you 51 cents. Then it's not equal to, so it's a two-sided. Okay, that's going to be two-sided. And that's it. The alpha is 5%. Okay, put the test result. That's it. It's 5%. Okay, look at the p-value. P-value is very small. This is the p-value. It's a 1%, almost 2%. And your alpha is 5%. So P is less than alpha. Look at this one, it's confirmed here. When P is less than alpha, we reject the null hypothesis. Let's see, that's it. We reject the null hypothesis H naught. If you reject the null hypothesis, so you have to accept the other one. So we conclude that the population mean is significantly different from 51 cents, and then we support the claim. Okay, so again, a screenshot. Or you have to give us this information. You set up your test, H naught, H1, the name of the test, okay, and then the conclusion, make a comment, compare the alpha and the value of your p-value, and give us the conclusion. Okay? You see the standard deviation, the mean automatically would be given to you. So this is two cases for the t-test. So you have two cases, t-test, z-test, but each one of them would have divided into three formats. You say less than, greater than, or not equal to. Okay, so that's it. We have one more, these two problems. I put one more so that you can see it. In these two problems, the information was given to you. Okay, then we set up the test, but sometimes the information would be given directly. So I want you to see where you are going to find it. You see this last one, number 13? Let's read it through to see what's the difference. Recently, the national average yield on municipal bonds has been, the mean is 4.19%. So that is a claim. Okay, that's a national things. Okay, a sample of 16 Arizona bonds gave an average of 5.11% with the sample standard deviation is of 1.50. Okay, so what we investigate, we pick 16 of the Arizona bonds and we find the average is 5.11. So this means easy, this mu is greater than 4.19. So we want to check it with the 5%. Okay, so this is going to be the case, but they give you the sample size of the S. So all the information is given. It's not like the previous one that you have to find it by looking at the numbers, okay? You have the average, so we can go ahead and do it right away. Okay, either case is going to be all right. So going back, build this information. This is the information that we have. Okay, the claim is that this mu is greater than 4.19. I didn't change it to the decimals because all of them are given in percent, so that would be fine. We check this one. So the claim is that the mu is greater than 4.19. Data information, n is 16, x bar is 5.11. These are all given. And we want to check it against the alpha. We set up the test, mu naught, mu equal to the 419. Remember, they want to check if it's greater than. Greater than. So it's going to be one tail test or right tail test. Greater than. Test stat. Since S is given, we have to use the T. So x bar minus mu s mu naught S over radical n if you want to use manually. You substitute that give 3.2 and the T naught is 3.2. Okay, then you have to find the p-value is a one-tail test. If you want to use the table, N16, df of 15, you go to the table, df of the 15, and the 5% on the top. You identify this number, you see df of the 15, df of the 15, and that 5% into the, you see 5%, that give 1.753. 1.753. But your number is 3.2, so you have to go to the right. Your p-value is going to be to the right of the alpha. And if you check any number into the one-tail area, to the right, you see they are all less, less, less. So p is less than alpha, you reject the H naught. If you reject the H naught, means you like the other one. You like the H1. So you have to write something positive. There is sufficient evidence to conclude that mu is greater than 419, and then you support the claim. Okay? So this problem is shorter because, information is already given to you. You can check it with the ArtStat to see if you get it right. Okay. So go to the application and drop this numbers done. Again, make sure you write, give us the H1, H naught, set up your test correctly. Okay, so into the application, Now for this one, we don't have the number, so we have to go to those short version. So we go to the summary statistic. This is summary. So we need a sample size. The sample size was 16. Okay, so the sample size of 16. Then we need a sample mean of 5.11, 5.11. Then we need a sample standard deviation, 1.15. Okay, what type of test? We are test significant tests, the one we are interested in. Value of the null, 4.19. What type of test? You see it's a greater than. Make sure you use the correct one, greater than. That's it, it's a greater than. So look at this. Mu equal to, for the mu naughts, greater than. Then the p-value is very small. Look at this, 0.0030. Alpha is 5%, so p is less than alpha as we did it. We reject the echelon. But if you want to see the result against the 5%, these are going to be the conclusion. P is less than alpha, you reject the H naught, so there is sufficient evidence to believe the other one. This is it. Alpha 5%, we reject the H naught. We reject the H naught, conclude that the population mean is significantly greater than 4.19, and you support the claim. Okay, a screenshot, or just give us this information in details. You have to give us the P, just compare it, show that the P is less than alpha, and they're writing the conclusion. So decide which one do you want to do, okay? So get practice because you have several of these, okay? Not only for this test, but also for the final. And when we get to the final, we are going to have, also we are going to have the variance standard deviation. So we have confidence interval for I will post those lecture notes quickly. In your book, they talk about quite a lot. You better read those lecture notes that I'm going to post it to be prepared for the final. And I post the final review because we need to have those information about the quickly variance and the standard deviation. So it would be the same for those. We have the test, but this. So get this done quickly and keep them for the final. Okay, there you are. So have a good one. Take care. If you have any question, okay, let me know. You know, sometimes if you need any feedback on your, I try to write. It's not easy to write all the details, but if you feel something that you need to be explained, you just send me an email. We can meet on Zoom, and I show you your paper, and we can talk about it. Okay, but get practice. Make sure you know where to find these applications, and give us the details in order to get the full credit. Okay, I will post all these recordings. Have a good one and take care.